Namaste. So now we know that computers know only one language, and that is binary. Yes, binary language. And the binary has only two numbers in this as characters or alphabet, whatever you say. 1 and 0. Yes, 1 and 0. Just two numbers in the entire language. Now, who taught this binary language to computers? How come the computers know this language? So here is a component. It is called transistor. What is that? Transistor. Yes, transistor. This transistor do have a particular characteristic. It allows and does not allow the current to pass. Yes, as we all know, all the machines need electricity. So even computers and all other related devices like mobile phone and tablets and even fitness band, they need the power, the current. And this transistor do have a characteristic. It works like a switch. What do the switches on the switchboard do? What do they do? Yes, it allows the current to pass and not to pass. It switches on and off the lights and the fan and the TV, the refrigerator, other electric devices. Similarly, this transistor works as a switch and it allows the current to pass and not to pass, depending on the program, depending on the situation. There's three-leg transistor. And now, in a particular device, a computing device, there is something called microchip. Microchip. Any idea what will be the size of those chips? It can be, the two as big as a 2 rupee coin. Yes, and it can be as small as your teeth, size of your teeth. Yes, it can be of the size of the 25 paisa coin, and it can be much smaller depending on the device. The fitness band. The band will have a very small chip, while the laptops will have a bigger chip, but again, as big as the 2 rupees coin. That's it. Now, the big question is, what do you think? How many transistors can fit in one chip, maybe as small as your teeth, or your nail, or just 25 paisa coin, 2 rupees coin? How many? How many transistors will be there in one such chip? Any idea? Just guess. 1, 2, 3, 4, 5. These are the numbers that we have received, from various kids when we asked them during the coding class. Any idea? Now let me tell you, and I'm sure you will surprise. It's an amazing figure. There can be 5 crores. Yes, 5 crores of transistors in one chip. 10 crores. What about that? What about 100 crores? 100 crores of 1 billion. Yes, 1 billion transistors in one chip. Forget about that. 5 billion. 500 crores. That is 500 crores. 5 billion transistors in one single chip, as small as the 1 rupee coin or 2 rupees coin, or maybe size of your teeth. The iPhone, the phone that we carry in our pocket, the chip of that phone, iPhone, does carry some 7.5 billion transistors in one chip. That is the level of miniaturization achieved. Now, what these transistors do? Yes, allows the current to pass and not to pass. Allow, does not allow, allow, does not allow, allow, does not allow. So sometimes the current is on, off, on, off. What are the other words we can use for this on, off? Any idea? Can we say yes, no, yes, no, yes, no, current is yes, current is no, current is yes, current is no. Can we also say 1 and 0? Current is on, that means 1. Current is off, that is 0. 1, 0, 1, 0, 1, 0, 1, 0. And that forms the language of computers. Yes, we got that. That forms the language of computers. These transistors are the magicians behind this language. They are the creator of this language. So now, hundreds and thousands, lakhs and millions and billions of transistors, when they work together for a particular operation. For example, when you are seeing this video, at that point of time, lakhs of transistors, millions of transistors are switching on and off in your device. Yes, millions of transistors are working together to deliver this video and play this video to you. So they create a pattern of 1 0, maybe 1 1 1 1 1 0 0 1 0 1 0 0 0 1 1 0 0 0 0 1 1 1 0 1 0. That is the pattern. That can be a pattern, and the computers understand that. There is a pattern created by these transistors through electric current, and we call them the binary language. That's it about binary. Bye bye.